Okay, Assalamualaikum. So today we're going to continue with 4.3, heat, specific, latent heat. So what is latent heat? Latent heat is heat that released or absorbed during the change of state of matter without change in temperature. So we have three states of matter. Okay, we should have 5 by now, but we just learned 3. So we have solid, liquid, and gas. Okay, during the changes of the state, means from solid to liquid, heat is absorbed, but no changes in temperature. Okay, the same goes to when liquid going to gas, heat is absorbed, but no changes in temperature. Okay, the other way around, when gas to liquid and liquid to solid, condensation. Okay, so what happened? Heat is absorbed, but no changes in temperature. So that is meant by latent heat. Okay, so we have three states of matter as I explained. So solid can become liquid, liquid can become solid gas, and the other way around. So during the process, no changes in temperature, but heat is there. Either it's absorbed or released, just the temperature does not change. Okay, so we have what we call melting or freezing. Okay, during ice, solid becomes water, liquid, so it's a melting process. Then becomes gas. Vaporization is a boiling process. So when you condense the gas, it becomes liquid, and you freeze the liquid or the water, it becomes ice or solid. So we have simple calculation on this part and explanation using graph. So latent heat is absorbed when you want to break the bond. Then when you want to mend the bond, okay, nak cantum balik, so object is heat is released. So now we go more specific. Define specific latent heat of fusion, and latent heat of fusion and vaporization. Okay, so apa maksud fusion? Dalam bahasa Melayu dia kata pelakuran, means cayak lah. Okay, vaporization, penguapan. So dia nak tukar jadi gas. Okay, specific, bila ada perkataan specific means tentulah. Specific latent heat, haba pendam tentu ni pelakuran ke atau penguapan. So the heat that is absorbed or released during the change of phase of 1 kg. 1 kg ni kita punya rujukan lah. Kita ambil sekilo something lah. Sekilo kayu ke, sekilo logam apa-apa. So kita nak cayakkan dia. Okay, ataupun kita ambil sekilo air, kita nak bekukan dia. Okay, of substance without change in temperature. Kenapa tak ada change in temperature? Tapi ada heat absorb or heat release. Okay, this is what we're going to discuss. Okay, this is the equation. Q equal to ml. So Q is energy. So energy in this case in form of heat lah. Okay, haba. Okay, so M is the mass. So we use 1 kg. L macam C yang sebelum ni. L is specific latent heat. Specific latent heat ni ikut jenis bahan yang kita guna. If water, dia ada nilai tertentu. Kalau kita guna let's say besi, dia ada nilai tertentu. Kita guna sirap ke, air mendung, nilai dia tertentu lah. So yang nilai tu semua tetap. Okay, so depends how much heat kita perlu untuk nak cairkan dia. So the unit joules per kilogram. So this is kilogram. Okay, joules is for energy. Okay, now we divide this to two parts. So we have latent heat of fusion. Ni kita cerita pasal pelakuran. Fusion ni kita nak cair from solid to liquid. Okay, heat or energy absorbed during melting. Okay, melting ni didih lah. Okay, peleburan. Sorry, peleburan lah, bukan didih. Lebur 1 kg of substance without any change in temperature. Tapi kalau kita nak terbalikkan dia, energy released during freezing 1 kg of substance without any change in temperature. Okay, so maksudnya kita ada solid, kita tukar jadi liquid, cair sikit. Ataupun daripada liquid tukar jadi solid. So ini kita panggil fusion. Okay, latent heat of vaporization. So perkataan pun vapor. Vapor ni gas lah. Sebab kita panggil orang hisap vape kan, keluar gas. So the heat energy that is absorbed during boiling. Boiling kita didih 1 kg of any substance. Dia mendidih from liquid jadi gas. Okay, tapi temperature tak berubah. Without change in temperature. Or the other way around. So the heat energy that is released during condensation of 1 kg of substance. Awak ambil gas 1 kilo, perap dia 1 kilo sampai dia jadi cecair, jadi liquid. So that is called latent heat of vaporization. Okay, pengawapan. So this one is solid to liquid, or the other way around. This one is liquid to gas, or the other way around. Okay, this graph you can find from your textbooks. It's very, very important. So your textbook on page 138 and 139. Okay, please read this part. Okay, you have to explain each of the curve, what happened to the substance. So this is heating curve for melting and boiling. So means this is about, okay, dia nak tukar, means we are absorbing. So kita tengah absorb heat lah, sebab kita nak jadi lagi cair. Okay, this is very simple to understand. Okay, for each part, P to Q, Q to R, R to S, and S to T. So 1, 2, 3, 4. These 4 parts, make sure you can explain. Okay, we start from P. At P, what happened? Okay, let's say this is a solid. Kita katalah ni satu ketui ais. Okay, solid. So nothing happen. So we start to heat. So kita panaskan dia. So temperature semakin increase lah. Semakin naik, semakin naik, semakin naik. So you can see kinetic energy masa ni tak buat apa lah. So kita start panaskan dia. P to Q. Then kita start panaskan dia. So kinetic energy increase. Kinetic energy ni apa? So bila awak panaskan, the molecule start to vibrate. Lagi panas dia lagi tergedi. Okay, the state of substance. So dia increase kat sini, no changes. Sorry, no changes in the state means dia masih lagi solid. Okay, ada tak perubahan? Temperature adalah. Ini let's say 10, ini let's say 20. So ada perubahan temperature. So ini bukan kita belajar latent heat. Ini kita belajar sebelum ni. Q equal to MC theta. Okay, then what happened here? From Q to R, the state of matter is solid and liquid. So ais tadi dia dah start cair sikit. Jadi macam dodoi lah. Tadi dia keras, terus sekarang dia jadi macam dodoi, macam paste sikit lah. Ada liquid sikit, ada solid sikit sebab dia dah start cair. So you can see temperature over here, from here until here is the same. Temperature sama je. Sebab apa? Kinetic energy does not change. Dia dah tak vibrate dah. Dia punya vibration dia tak berubah. Cuma the heat supplied from the increasing of the temperature is used to break the bond. Okay, dia ada, you belajar kimia kan. So dia ada pegang antara molekul tu. So daya covalent bond ke ionic bond tu dah dipecahkan. So heat ni kita terima untuk pecahkan. So bila dia pecahkan, dia dapat heat, dia pecahkan. So, that's why temperature tak naik. Temperature dari sini ke sini sama je lah. Okay, digunakan untuk break the bond. To break the bond between the molecules. Okay, to break the bond. So at point R, sampai kat sini dah habis lah. So sampai kat sini, 100% jadi liquid. Okay, then the same process happen from R to S. So dekat sini, Q equal to ml. Okay, no changes in temperature. Sebab tu tak ada theta kat sini. No changes in temperature. Okay, now from R to S. What happened? You can see there is increment in temperature. Ada peningkatan suhu. Untuk apa? Untuk dia increase lagi kinetic energy. So bagi lagi kuat tadi. Dia dah cayak, dia terima heat, dia jadi lagi senang lah dia nak vibrate. So lagi tinggi lah temperature dia. Dia dapat heat, dia vibrate. So pecah lagi molekul dia. Okay, until point S. Okay, the same explanation. Okay, what happened at S? Dia dah start jadi gas. So heat yang bagi kat dia tadi, dia dah tak guna pun. Heat tadi tak guna ke, dia break the bond between molecules. So dia nak bebaskan diri dia. So dia dapat heat, dia dah tak guna untuk kinetic energy, tapi dia guna untuk break the bond. Okay, so this explanation equal to this explanation. Just the state of matter is different. Same goes to here. This part of explanation equal to this part of explanation. Okay, so what happened here is heat is absorbed. Sebab apa kita nak absorb? Sebab kita nak break the bond. Okay. For this graph is the other way around. So in this case, you can see the same process. Okay, reverse process. So what happened? We start with gas, then temperature decreases. Temperature decreases means heat is released. Heat dalam dia tu guna untuk ketar, untuk buat dia bergerak kinetic energy. So you keluarkan heat tu, dia kurang bergerak lah. Dia kurang bergerak, daripada gas pun dia jadi liquid lah. Dia dah start melekat lah dengan kawan-kawan dia. Okay, so dia akan jadi gas kat sini. Sorry, jadi liquid. From gas jadi liquid. So from here pun sama juga. Okay, the explanation. Okay, you release the heat. Okay, temperature decrease because kinetic energy start to decrease. Okay, then what happen? The state of substance remain unchanged until point B. So kat sini masih lagi gas. Sampai kat sini dah jadi liquid. Okay, you can see no changes in temperature over here. Okay, so until point B to point C. Then again, okay, B to C, no changes temperature. The heat is used to strengthen the bond. Okay, kat sini strengthen the bond. So dia akan jadi liquid sepenuhnya. At point C, start to become liquid. So this one gas plus liquid, this one liquid. Okay, C to D, temperature decrease, kinetic energy decrease, the state of substance remain unchanged until point D. Okay, sampai ke sini, D to E, again, same explanation. State matter is liquid and solid, temperature is constant because kinetic energy does not change. So, you baca balik yang atas tadi, you reverse the process. So, this part you can, again, find out in your textbook, page 139. Okay, so the question might ask you kat sini, dia keadaan apa? Solid, gas, or liquid, or plus solid and liquid. Kat sini, bahagian apa? Okay, the same goes to this graph. Question can ask you, okay, QR ni, liquid ke, solid ke, atau liquid and solid? Kat mana melting point? Kat mana boiling point? Okay, so all those part, make sure you study the graph. Okay, so this is the example, the animation, you can see what happened. Okay, from solid then becomes liquid. Okay, during this process, no changes in temperature. Okay, because the heat is used to break the bond. Okay, this is another example. So we have initially 27 Celsius. So then you start to boil. Awak boil sampai 100. Awak tengok temperature dah tak naik lagi dah. Tapi dia dah tukar jadi gas. Okay, gas keluar, pengit, keluar kan. Sebab dia guna semua ni untuk pecahkan bond dia. So sebab tu dia keluar jadi gas. So kalau kita tak thermometer, still 100. Okey, selagi dia tak habis yang dalam ni, duk satu-satu. Okey, selagi ada liquid dalam ni, selagi tu dia cuba pecahkan. Alright. Application. Okey, application ni senanglah baca sendiri lah. Okey. Untuk sejukkan, awak tengok kat market apa semua, orang jual sayur, ikan, siapa ada bubur ais. Okey, kita bubur ais so that heat dalam ikan ni keluar pergi dekat ais tu. Okey, dia keluar dekat ais tu. So, bila ada kurang heat kat dalam ni, dia susah nak rosak lah barang ni. So, during the ice melting, a large quantity of latent heat is absorbed from the fish. So, fish ni pergi ke ais tu. So, ais tu yang cair. So, panas-panas dalam ikan tu dah keluar. So, bila panas-panas dah keluar, ikan tu tak rosak lah. Sama lah dengan kes sayur pun. Sebab tu barang semua kita buang freeze kan. Kita tak buang microwave. Okay, problem solving. Okay, so now we have simple calculation. A solid with mass 2 kg is heated by 100 watt emission of heater. What does melting point means? Melting points means takak lebur. Takak lebur is where solid turns to liquid. So, ini senang lah. Semua boleh jawab. State the melting point. So, melting point 20 or 80. So, they start to melt. So, 80. No problem. Ini senang sangat. We go to the calculation. Calculate the specific latent heat. So, specific latent heat, Q equal to ml. So, this one is heat. Heat is energy. So, this is the mass. This is what we're going to calculate. But, the question is, what is this? Heated by 100 watt. Watt is about power. So, dia bagi power. Kita nak guna energy. So, what is the relationship? P equal to Q over T. So, nak cari. So, P is given 100. T, nak ambil mana? T is time. That's why the graph is given. Okay, so from the graph, time start to melt from here to here. So, T is 600. Okay, jangan ambil T dari sini, dari kosong. Sebab, soalan tanya, latent heat of fusion. Heat of fusion happens kat sini, ke sini. Kat sini Q equal to MC theta. Okay, so kat sini Q equal to ML. So the time is from here to here. So do your calculation. Once your Q is correct, replace in the equation. So we get the answer. Make sure answer with unit. Another example. Graph below shows a heating curve of a liquid of mass 0.5 kg. Specific heat is 250 joules per kilogram and latent heat is 3 × 10⁴. What does specific latent heat of vaporization means? Okay, vaporization means absorbed during 1 kg of liquid gas without any change in temperature. Okay, that is standard definition. Explain why the temperature has not changed. Why aspiration does not change? Because it's used to break the bond. Yes, good. Break the bond of the molecules. Calculation part. Calculate the amount of heat needed to turn the liquid into gas completely. Okay, so we start from here. Then here. So we have two parts. This is the first part. This is the second part. Turn to gas completely. So this one, liquid needs energy enough, then baru nak start break the bond. Okay, so means this part pun kena kira, this part pun kena kira lah. Sebab dia bukan tanya soalan, macam soalan tadi dia tanya latent heat je. Sekarang dia tanya energy needed, heat needed. So you have from this one is Q equal to MC theta, heat specific. You have changes in temperature 80 and 20. This part is latent. You have no changes in temperature. So we have two parts. Okay, so that's all for today. Our next class is about 4.4. Then we do a live class on the summative question. Thank you.